What's up, manufacturing all-stars? Today, you are going to learn about one of the best digital twin solutions in all of manufacturing, called Emulate3D. Now, if you've been watching Manufacturing Happy Hour for a while, you know that we've done a shorter episode on this before called How Digital Twin Technology is Used in Manufacturing. That's about 12 minutes long, but today's conversation is going to be much more in-depth because it's going to cover a demonstration as well as a presentation at the start. Now, this was recorded during one of our recent Manufacturing Happy Hour community happy hours. More on that in a second. But our featured guest today, who's going to be leading the demonstration, is Tyler Phillips. He's the longtime GM of Emulate3D in the Americas and has a big history with software, simulation, as well as visualization throughout his long career. Really excited to have him talk to you. But just since this is a long conversation, I do want to give you a little preview of some of the things to come if you do want to skip ahead. Around the 13 or 14 minute mark, that's where we really get into the demonstrations, where we start with a canning and filling line. Closer to the 19, 18 minute mark or so is where we're going to have a lot of different discrete applications like brick palletizing, cookie making, tons of different things. So if you do need to jump ahead, you can do that. All timestamps are in the comments below, so if there is just one thing you're looking to get out of this, you can move to that part of the video. But I would encourage you to stick with us at the start because for the first 10 minutes, we're going to do a quick presentation around the three biggest things you can take away about Emulate3D, and that covers demonstrations, simulations, as well as emulations. So it really covers the full spectrum where demonstrations are something you'd really use in the front end of a sales cycle and then we'll go through that to simulations to emulation, which is really the digital twin aspect of Emulate3D, where you can use it to mimic a controls program. You actually hook it up to your controls so you can do virtual commissioning. This saves insane amounts of time. So I'd highly recommend to stick with us from the start if you can. Now, I did mention that this was recorded during one of our Manufacturing Happy Hour industry community sessions. If you're interested in joining that, you can go to manufacturinghappyhour.com/community to join our group of over 200 manufacturing leaders. That will take you directly to LinkedIn, where this group lives. That's where we schedule our conversations. We do sessions like this once a month, if not more frequently, like once a week was what we were doing at the height of the pandemic, where we'll do networking sessions. We'll bring in leaders in the manufacturing industry to do fireside chats, or in the case of today, we'll do an in-depth technology demonstration. Anyway, enough of an introduction. Let's get you some information. Let's get you a demonstration around Emulate3D. I'm excited to hand it off to my friend, Tyler Phillips. Stay innovative, stay thirsty, enjoy the demo. Cheers.
So let me take a few minutes just for those of you, some of you have actually, I think, been through a demo with me with one or more prospects, but I just want to go through a brief orientation of what Emulate3D is and how we talk about it. Because, we talk about digital twin, we talk about emulation, we talk about simulation, we talk about digital thread, we talk about controls testing, and all these terms carry baggage with them. And so as soon as one of them is said, whoever hears it is going to attach whatever they know about that term or whatever they think they know about the term or whatever that term means to them to that word. So let me level set on a couple things of what we do with Emulate3D, what we don't do, because that'll help you determine where you might have fits and where you have opportunities. And then I just want to talk about it, and then I'm going to just bring up some videos and let them play for a little while we chat, and then we can do whatever. So I'm here with you for the time and happy to do it. So when we talk about whether the term digital twin or whether that term is digital thread or whether that term is controls testing or virtual commissioning, we always come back to these three core terms: demonstration, simulation, and emulation. And when we talk about those, the reason we talk to those is we think we can eliminate some of the clutter that sometimes is attached to terms. So right now out in the world, if you hear the term digital twin, you'll hear a lot of people saying we do digital twin. And when you dig down to the heart of it, they've grabbed that term because it's kind of popular, but what they do isn't really what we would think is digital twin. So we use these terms emulation, simulation, and demonstration to talk about creating 3D models that are used for things like sales purposes when we talk about demonstration, to create 3D models that are used for things like testing throughput of a system or time in state or utilization. That would be simulation, something that's all self-contained. And then we talk about emulation, or the alternative terms would be a digital twin or a virtual commissioning commissioning or controls testing, and that is creating this digital model that can be connected to external controllers in order to test the interaction of the equipment or the system and the controls. And that's what we talk a lot about in the kind of since the acquisition and being part of Rockwell, because obviously that's a huge fit, and that's where we were an Encompass partner before, is because of that connection. But I also don't want to downplay the fact that this can be used by itself standalone in simulation, or what we would call demonstration or simulation mode, and there's a lot of application for that as well. And probably, I'm guessing just now, but fully half of our customers probably haven't yet ventured or may not ever venture into the controls testing space, but find a lot of value in the simulation part of it. So in talking about that, I just want to go briefly through just three things and three terms. Then I want to show you some videos and talk about, just real briefly, I'll breeze through them, and then we'll let them run on a loop. But so when we talk about the Emulate3D software, we're talking about a single application, a single framework, but we license it out at different levels. So you can license out in a level called Demo3D, or a level called Sim3D, or a level called Emulate3D. And depending on those licenses, you will have a different feature set. And Demo3D kind of applies to that demonstration modeling, Sim3D to a self-contained simulation of a system, and Emulate3D to controls testing. But let me go through those individually really quickly. So Demo3D is this ability to use this core model in the 3D space to create a visual experience that you can have shareholders share, right? So whether they're all internal, whether it's internal and external, whether it's a customer and a vendor, whether it's a customer and a consultant, the ability to get into a system, whether that's looking at it on a screen, sharing a video, getting in virtual reality, the ability to share that experience and thereby get buy-in and effectively communicate. That's that kind of core Demo3D. In addition, that core Demo3D is the model building environment. It's where we always live when we're doing anything. And so on top of that, if you will, on top of that Demo3D, we can inject this experiment management where we can, you'll see in that top window there that kind of looks like a spreadsheet, we have 5 different experiments set up. We have a different number of bays, a different number of shelves, and a different number of vehicles in a storage and retrieval system. And we're going to run experiments to see what happens with those different variable combinations, and then look at the throughput. So we turn that all on, set up, set it, go away for the night, come back in the morning, and depending on how long those models run, we then have our, for example, throughput, or we might be looking at time and state or utilization, or we might be looking for specific bottlenecks, or we might be experimenting with different types of demand, or even different layouts to look at which one is going to meet the needs of the system. And that's the Sim3D part, if you will, of Emulate3D. And then on top of that Demo3D core, we can also create these dynamic digital twins that define all the IOs of the system. And then actually, instead of having a simulated world where those things are controlled by different types of logic to say how does the system work, we simply connect via server connection to the actual controller, right? So we're connected to the compact guard logics, or we're connected to whatever, and it doesn't have to just be Rockwell product, it could be a variety of other product, and that control logic is going to drive the model. We aren't importing the logic and interpolating it in any way. We aren't pretending we are acting like the controller. The controller is actually control it. And we can do that through an actual controller. We can do it, for example, through Logic's Emulate, but the highest fidelity comes when we have that actual hardware attached. So that's 3 levels: Demo3D, Sim3D, and Emulate3D. Again, those are all in the Emulate3D environment. They're all the same application. It's just how we authorize that. So someone who may be a little bit averse to getting into a software that's going to cost them $35 or $40 or $45,000 to do controls testing, because they don't want to do controls testing, but they have some significant opportunity to demo their systems. They may be able to get into a license of Demo3D for $20,000 and fit all their needs, right? If we look at these from a kind of project progression standpoint, it's another way to think of these kind of different feature sets. Demo3D generally used at the front end of kind of processes or or the front end of the design process or the prototypical process of saying, hey, we've got either a green field or changes to a brown field. Here are the options. Let's look at it. Let's get everybody on board. Let's see how it's going to fit. Let's see how it flows. Let's make sure it fits in the facility. Let's make sure we have enough space in certain areas. Let's make sure the flow is correct. Once we've narrowed that down to kind of the system we think works, then we can use Sim3D to analyze with that system, experiment with it, and determine does it meet the requirements of the system. For example, I had somebody I was working with just the other day who said, look, this system has to meet a 40% increase in demand, which is what we project we'll have next fall as opposed to this fall. So they're able to build their system out and use different sets of demand, injecting loads, if you will, loading up that system at different levels and say, oh yeah, it will. Or guess what? We don't have nearly enough, for example, packaging areas or palletizing areas, or we have a bottleneck at this machine. How are we going to make sure that's future-proof for what we need? And then once that design is locked in through this experimental process, we can then take the Emulate3D controls testing part of it and test the controls. Those can be intertwined. Those can be independently done. For example, we have customers who, for whatever purpose, for whatever reason, they say, we're really good at designing the system. We just need to make sure the controls are right. Or others who say, we don't do controls at all. We just design systems. Somebody else is going to write the controls, but we need to make sure the system will theoretically meet the demand before we get there. So just one more slide, and then let's look at some videos and talk to them. So as you're thinking about this, and as we're talking to stakeholders and prospects and customers and things like that, what are the value propositions? Well, they're pretty wide. And they're also fairly deep, and so it depends on the application, it depends on the customer, it depends obviously what they're using it for, but generally speaking, these are the kind of things we're looking for and hearing about from users. Demo3D, ensuring that all their stakeholders are able to share the project vision in a coherent way. So you've got people over here working on spreadsheets for throughput, you got people over here looking at a CAD drawing, you got people over here who are doing the finance, and then you got a systems integrator who's trying to get all around that, and suddenly you get them all around a table, or in our world that we're living in today, all around a screen, or all around screens, and they go, you know what, I had no idea that's what it was going to be. That makes total sense now. You guys kept telling me that it was going to fit, and I just couldn't figure out how it would, but now I can see how the flow works right, the system fits our facility, great, right? So it can be a great sales tool, a great project kind of sharing tool, and a way to reduce development time by getting those concepts quicker. Sim3D, the main goal there is reducing risk in investment and reducing risk in you know, problems that come up without fully analyzing a system and how it meets the needs. And last of all, and you guys have probably all seen the slide that we use sometimes, it says take controls testing off the critical path, move it up under the design phase, and get it out from the area where it can be highly compromised. So we're not spending 3 weeks on a floor with a customer, we're spending 3 days because we've already done 90% of it. And that's where that controls testing part comes in. So let me close this screen and see if I can do this very well. We'll see really quick. No, that's not the one we wanted. Hold on just a second.
Take your time, Tyler. I do have a question, maybe a bit of context.
Yeah, go ahead. Yeah.
I want to throw out there. So I have heard that this is on the emulate side, kind of like the far end, the digital twin end of the spectrum. Like that's a tool that's allowing people to reduce their on-site commissioning time by like 90%. Is that accurate, or am I over-exaggerating?
No, you're not. We do certainly get reports of that kind of savings. We routinely, let me just make sure we get this new screen sharing here. Let's see, where is it?
Looked like it was working there a second ago.
Was it working there for a minute?
I saw it. And can I just get some head nods where other people seeing some simulation in the background? Looking good.
Yeah, let me get rid of this here if I can. Well, cancel that. Okay, let's try it again. Can you guys see a video running here?
Yes.
Okay, good. I'm just going to see if we can get these running. They may run on a loop. I think they are. Yeah, so that's a really good question. So we get customers who, obviously, the experience they have can be highly variable, but we get customers who report all the time, we have reduced our field commissioning time from 3 weeks to 3 days, or we've reduced it from a month to a week. So how you calculate, you know, how much are they getting done virtually instead of in real time it can be a little bit tricky, right? Is that 75% if you're going from 4 weeks to 1 week? Well, maybe, but you know, sometimes the last 20% of the work takes 80% of the time. So it really depends. But we do see people reporting that, and you know, saying things like, 2 hours in the lab saves me a day in the field. So the goal is to get to that 80, 85, 90% kind of range where we can start saying, hey, I've accomplished these things before going to commissioning. I don't have to do them now. My fat is essentially done except for my 12 checkbox items that I can't do otherwise. And some of the things that people experience, especially, are things that they would love to do in commissioning, but by the time they get to commissioning, they're either too time consuming, too expensive, too dangerous, or maybe they're always that way, right? Too much raw material gets burned up. Too much time is taken by a facility being shut down or a line being shut down. I'm going to advance to another slide here. I thought I was playing a loop, but we'll see. Here we go. We'll just let that one play for a minute. So it is going to be variable. Yes, those are accurate. You know, I'm sure there's cases where people have less depending on what they're doing. We also, however, you know, there's people who will be using one thing. For example, they may be doing a commissioning project, but they will also come upon things they didn't realize. We had a really interesting experience in our user group meeting last year where somebody came to present on commissioning it was a bus body paint line. So they're actually painting, you know, like Bluebird buses, right? The big bodies. And the job was to commission, but what happened is once they got the layout from the system designer and they were going to start working on commissioning, they first created the system, made sure the flow was right, and they found out that the design was bad. And what happened is they had put the end of the paint booth too close to an external wall, and so they had to turn the power and freeze system pretty tightly. And when the dogs pulled the body around, if they'd actually had that as a real system and turned it on, the rear end of the bus was actually going to crash through the side of the paint booth. Well, it sounds kind of silly and stupid, but until somebody visualized it, they said, well, wait, we can't do the commissioning on this yet because you know what? The system it's not going to work. We're going to ruin these paint booths. So they actually caught that very early on and were able to get redesigned. And so not only did they save the time they would have with commissioning, but they caught a real big error that nobody had seen just by kind of, you know, the static work that had been done. So let me zip through these really quick just to give some examples of what kind of things Emulate3D gets used for. First of all, you know, we get used heavily in manufacturing and material handling, right? This is a discrete event simulation software at its core that works together with physics engines. And the kind of physics we're talking about are essentially Newtonian physics, right? What we would call rigid body volumetric physics. So we're talking about the size and shapes of packages and equipment and things like that. We're talking about gravity, friction, speed, mass, and time. What we're not looking at are things like finite element analysis or thermodynamic analysis. So we're not going to tell somebody, hey, you spec the wrong motor, it doesn't have enough torque. Or we're not going to tell somebody the sheet metal you used is too flimsy, it's going to bend when a box hits it. But there's a lot of assumptions made before you get to this point, and that is that the design itself from kind of a DFM standpoint has been done correctly, but we're concerned about how the controls and the system interacts with a loaded system when the loads are in it. So you can see here, this is just kind of a little demo of a Quimrock system. So it's got some tires and some totes and some boxes and things like that. But those are the kind of objects we're talking about: bottles, tires, boxes, car bodies, those discrete things that are moving around in a system. Some other examples here. This is a really interesting example that uses our new CAD as the model technology, where this is by a consulting company in France that built this very detailed model of a brick palletizing system, essentially. So these are pallets of bricks, very heavy industrial bricks, looking at making sure the controls are right. You see it's beautiful CAD. This was CAD that was given by the customer, the manufacturer, the vendor of the equipment, so that as this company was doing the integration, they could do some analysis here. This was a fully emulated model. This is a video captured from that. You guys, some of you have seen this one. This is a model that was put together by Haskell for this cookie baking line. This is cool because it has actually a mixture of discrete and continuous, and the continuous is kind of extrapolated. We're not worrying about, for example, the pressure in the tank or the recipes, but we are keeping track of when it becomes empty by decrementing the volume in there. And this is one you've probably seen maybe at Automation Fair or something like that. This is a little mail sorting facility. This was their first kind of demo model they put together, where they're actually filling boxes with certain kinds of paper, and you can see physics are actually working there. Physics with paper are interesting because if the wind blows, you have a different thing going on. A company called PSI Engineering. This is a model that we created for a prospect up in Canada that makes these pan stackers for baking, for industrial baking. I don't know, some of you have probably seen stuff like this. It's pretty cool to go to an industrial baking show and realize that everything we eat, even stuff that we never thought of as being industrialized, is made like this. And you can see in this model, for example, all the magenta cones up at the top are actually sensor fields that are being counted for by Emulate3D. And when a pan reaches the sensor, it signals all kinds of things to happen. The elevator that's moving the stack up stops, an arm reaches down, it grabs the pan, it moves it. And so we can do all this kind of very detailed modeling up to and including all the IOs from things like the sensors and the motors and the lifts and those types of things. And then I think there might be one or two more in here. Let's see if we can. Well, that's the last one in the loop. So we can zoom back really quick because some we didn't talk about, just so you know. So this is a really cool model that was from a customer CAD of a pharmaceutical insertion machine. I don't want to make anybody think all we do is just local machine stuff, because you can model very large systems, but more and more people are concerned about specific machine controls. Here's one, some baked bean palletizing that shows how the physics work. And this one was one we showed at PAC Expo. This is actually a machine that was at PAC Expo. It's a little poker chip machine. So those Delta robots are picking up the poker chips off of the conveyor belt and putting them into a little sorted area. And that's one we had emulation running on as well. And then back to the can or the bottling line. So I'm just going to let this run through the loop, and I'm happy to answer any questions and just chat if you'd like.
I'll also throw one other thing out there, since this is our digital twin session. I encourage you to ask questions to Tyler, but it's also fair game, since this is a happy hour. It's not a webinar. It's also fair game for this to become a let me call it a democratized digital twin discussion. Hear what you guys are seeing in your experiences so far. You know, it looks like there are 20 of us on the call today, so I know some of us have dealt with this already. Some of this is new to some of us. Some of this is out, for those of us that are marketers or in e-commerce, outside of our scope a little bit. But, just so you know that the conversation can be a bit broader and not necessarily just questions for Tyler, but definitely hit him up because he is the expert on this if you have questions.
Hey, Chris, it's Oliver and Tyler. Thank you for a great presentation. A question for you, and there's a couple questions in the chat that I want to make sure we don't lose as well, but the one that I want to ask is, this is a ton of, it looks like a ton of computing power. Is this something like a normal engineering laptop can run if the CAD model's already done?
That's a great question. Yeah, so the hardware that we recommend, because as you have noted, well, first of all, many of these videos I'm showing you are rendered. So these are actually MP4s that I'm playing, and they've been rendered out of the model, some of them frame by frame over who knows how long, a week maybe, right? But I can actually pop open. That's a good point. Well, let's see if I can do two things at once. So I'm going to close that. I've got a printer queue that's going crazy here. I'm going to see if I can actually share a screen with you guys. Let's see what happens. Did you see an Emulate3D window pop up there?
Yes.
Okay, so
you're very brave. Live demos are always dangerous.
After you've done it for 10 or 15 years, you face.
This is also the lowest pressure presentation anyone will ever do.
Yeah, that's right.
You can blame it on the beer if it doesn't work.
Demo. If anybody says, hey, show me a demo, we'll do it. So you guys should be able to see I'm rotating this floor around, this grid. Yeah?
Yep.
So now I'm actually live, and so you'll see the difference. Let me just go ahead. I'm going to go to my quick start catalog and I'll just rip something out really quick here. So I'm doing this for perspective. So I'm running a Alienware laptop. It's got a GeForce card. I think it's either an i7 or an i9. I think it's a quad core, and they're pretty fast cores. But I think this is probably a $3,500 laptop 2 or 3 years ago. So it's not like we're running a Cray computer or something like that. I got a free animator here, or a free load creator. Let me just put a couple actions in here, see what happens. Palette wrapper, I'll put a little profile checker down here at the end. I don't know what we're going to do with that. Maybe we'll put it up here. Anyway, so I'm just going to run this. We'll get some palettes created. So you can see that right away. I mean, you're probably losing maybe 20 or 30 or 40% frames by casting. I'm seeing a super smooth model. Those pallets are just beautifully running down the line. No problems, anything like that. The pallet wrapper is going to rotate around. I haven't put any boxes on or anything. So to answer the question, yeah, an engineering desktop laptop in the kind of what we'd call a gaming computer, a hot gaming computer, runs just fine. We recommend faster cores rather than more cores because discrete event simulation, as nobody in the world yet has discovered a way to do discrete event simulation in multi-threaded processes, so it runs on a single core no matter what. But a lot of the stuff we do will take advantage of the multi-threads. So yeah, you know, people, I actually have a little Lenovo Yoga that's 4 or 5 years old that I can run a license on and I can do small demos. If I was to start, you know, making a ping pong ball factory, I might have problems because I'm going to render every sphere, and that gets to be problematic. So that gives you an idea.
Hey, cool. Thanks. Great presentation.
But most high-end CAD, you know, if somebody's got a CAD device or a CAD computer they're already running, it'll run Emulate3D just fine. We are DirectX, and that's why we recommend the GeForce over the Quadros. Quadros, you're going to spend 3 to 10 times more for the same performance because we aren't taking advantage of the OpenGL.
Good question, Oliver. Also, I'm looking at this. One person did pop a question, and it came from default, so I don't know who it is, but Kyle Rogi was going to follow up with it too.
Maybe it's that one person I said that, you know, I liked everybody at Rockwell except that one.
The question is a plugin available for RoboGuide to leverage the simulation data from that software and bring it into Emulate3D?
Whoever asked that knows the answer, and thank you for asking. So yes, the answer is yes. So we have been developing over the last year or so, partly because we've been able to. So Fanuc has released, or as some people like say, Fanuc. That to me that sounds like an Eskimo name, so I call it Fanuc. They have released a new API for RoboGuide that allows us to access essentially the controls data from a RoboGuide program. So we've created a plugin where essentially you can tie into RoboGuide just like you would a controller. So if you've programmed a robot in RoboGuide, we automatically can import the CAD, so we can get that from Fanuc and the way that robot works, and it will run in the model just like it would, just like RoboGuide would tell it to run. So the RoboGuide becomes a de facto controller, and it doesn't have to be exclusive. So you can when you go in and you go to our tag browser, which is here, right? This is how you connect to a controller. And if I go to my controllers and I want to add a server, I can choose. I can't find anything here because I don't have anything connected, but I can go to different protocols. I can go to different PLCs. And I don't have to be limited to just one. So I could go pick my Allen Bradley PLC. I'm not going to connect, but then I could also go connect to RoboGuide. And once I have the tags defined over here in the tag browser, and I have all my IOs and the expression and the tag values, you can run thousands of tags against multiple controllers. And that controller could be Logix Emulate, it could be a Siemens controller and a Beckhoff controller and an iteration of RoboGuide, all running different things in the same model, if you will. So thanks for the question. Yeah, absolutely. And by the way, we're releasing that on a as approved basis. It's not in the current 2019 release. It will be put standard in the 2020 release, and it's a no-cost add. Anybody who has a controls testing or higher license has access to that, just like they would if they go in here and add a server, just how they have access to communication with all these different protocols and with all the different, all the different devices. Okay. What else?
Let's see. Looks like another one just came in from Arjun. How does the license/subscription cost model work? Annual renewals, monthly?
Perpetual. The licenses are perpetual, which is based on a couple things. One is we're not doing it because it's the way we've always done it. It's the way we've always done it because this software is generally bought tactically and not strategically. So it's difficult sometimes to support a subscription model because we leave a bunch of money on the table. So there's not a lot of price elasticity. If somebody needs this, they need it. And it's generally more than justified, and the ROI is very good. So the models are, the licenses are perpetual. You buy the license, you own it forever, and then there's an annual support and maintenance fee after the first year to include, new updates, new releases, bug fixes, as well as access to technical support. There is one exception to that perpetual issue, and I'll tell you what it is because you'll see it in the portal. You can buy an Ultimate license on a subscription, and Ultimate is the most expensive, highest license. But again, I don't bring it up and I don't mention it much because my job is to, one, make sure the customer is happy, and two, that we generate the best revenue profile for the company. And I think in almost every case, that speaks to a perpetual license, not a subscription. But we have had some exceptions where we're doing subscriptions for that Ultimate package. Anything below that is perpetual. And maybe to add to that, and one thing they tell you as a salesperson over your lifetime is never answer unasked questions, because all you do is confuse your customer. But since we're all in the same team here, just so you know, the licenses are all deployed as they are authorized via server. The software itself is not served because it has to be run locally, but the customer can choose to either receive a network hardware key, and then they load a small piece of network license server software on their own server, and when somebody locally tries to access the software, it'll look to the server for authorization, or we can do that through a universal licensing service that we maintain. That's not yet integrated, and I don't think it will be anytime soon with the broader Rockwell licensing scheme. That'll come over time.
Two related questions, or I should say these next two questions are related. Talking about integration with SolidWorks, going from a CAD model in SolidWorks to Emulate3D, and then shortly after that, like support for Creo as well from the PTC side.
Perfect, thank you. So if you look at the screen here, I just popped up a menu bar called CAD is the model. This is a dynamic ribbon. It's totally customizable. A customer can take some of these off. They can put other things on. They can add items. For example, if they have specific sensors that they've built models for, they can include those here, so they can click them and say, this item is a sensor. And the way this works is I'm just going to create just really simply, I'm going to create let's see here. I'm going to create a new, just a basic object. So we have these basic objects. Let's just call it let's just create a box. So there I have a box. Right now that box is nothing except an image. Let's, if we can, let's change the color of it to something else so it's a little more visible. Whatever, gold. There, that's easy to see. So that's a box, right? There's nothing about this box except that we can see it. But using this CAD as the model toolbar, we've separated the geometry from the function. So I can go in and, for example, I can touch this, select it, if you will, and I can go into loads and I can say, well, let's see, do I want to make this, I'll go to physics. I can say, now it's a rigid body. I just made it a physical rigid body object. And then I get these menus that I can go up and start to add the attributes. This is the same thing you can do in SolidWorks and Inventor. So this ribbon installs into SolidWorks and Inventor, and it allows you to apply all these aspects to the actual SolidWorks or Inventor object. That information will remain in SolidWorks and Inventor with the CAD. So if that CAD has to change, you don't have to re-import, re-export, re-import, and reassign everything, because they can be quite complex. If you remember some of the videos, we had that pharmaceutical insertion machine. I think that had 140 different joints. And if somebody said, well, that wasn't quite right, here's the new CAD, and you had to start over again, you're probably talking about days to do that. So yes, that's for Inventor and SolidWorks. So Creo is an interesting beast. So Creo does not support dynamic toolbars. So we've had some real challenges to figure out how to insert this. And we've come to a couple, we'll call them, let's call them rest stops. Let's not call them ends or conclusions. So one is we've created some for, I think, 4, 5, and 6, Creo 4, 5, and 6, we have an exporter tool that allows you to take a file directly from Creo and put it into our our intermediate raw 3D or demo 3D format without having to go through STEP or IGES, which is really good because it retains a bunch of properties. We cannot yet do this aspect assignment in Creo, but you can bring it in as an object like this and then start to assign it in Emulate3D. Also, since the acquisition of Onshape by PTC, it seems, based on kind of what we think we know and what we've heard, that Onshape is going to be the future and that Creo may start to be pushed aside. So we're trying to figure out exactly where that development goes. But we've got exporters with Onshape, Creo, and Revit. So you can plug those in and you can export very nicely from those tools. And then we have the plugins with this full active toolbar for SolidWorks and for Inventor. As well as, by the way, and I'll just show you, whoops, let's see. So this, we can import a pretty wide range of file formats. So there's the file formats we can import, okay? You know, DirectX, Autodesk, Inventor, Blender, SketchUp, Collada, there's Step and IGES right there. Wavefront, Vermal, SolidWorks, we talked about, Solid Edge, point clouds. So in almost every case, somebody the other day, or no, just earlier, I guess, was saying, we don't have access to the CAD, but the vendor of the equipment said they could give us a step file. Will that work? And the answer to, in most cases, yeah, they'll be able to bring that in, and then they'll be able to use this CAD as the model toolbar to start to assign the aspects to make it a smart piece of a smart equipment, a smart thing.
Got a follow-up question, but one more popped in. What's the largest Emulate system that you're aware of in terms of axes and I/O points? We have a lot of folks on here. I mean, I think, well, I shouldn't say everyone, but a lot of folks that are in the discrete space. I'd be really curious to know that too, like that you're aware of, Tyler.
Yeah, it's an interesting question that I don't have an answer for, but I could give you some ideas of scale. And there's a couple reasons that it's difficult to get an answer for. Is that because we don't maintain, we aren't the modelers, we're the tool, we create the tool. Our modelers are out there doing things all the time, meaning our customers that we're not necessarily aware of. So it's likely that anything that we know about is probably surpassed by something else. But we routinely see customers that are building models with thousands of I/O points and multiple controllers. So they might be running a model with half a dozen or a dozen controllers and thousands of I/O points. Now, there are issues that would need to be considered. There's communication speed that needs to be considered. So if you're trying to run, 5 millisecond updates and you've got 1,000 I/O points, we have a problem because that blue cable that's running from the server rack or from the controller to the computer is not fat enough to do that, right? I mean, I'm being euphemistic here, but that's just the reality. So there are instances, and certainly we have seen customers that have built emulation models so large that they've had to break them into multiple models. Now, that's not generally problematic because in most cases, that's the way you commission anyway. You don't turn on a airport baggage system and see if it works. You say, okay, we're going to do the check-in desks, that works. We're going to do behind the wall, that works. We're going to do the security system, that works. We're going to do the the sorter, that works. We're going to do the air side, that works. And so in most cases, in almost everyone I've seen, we can certainly model and emulate at a much larger scale than you could do in reality. So usually you're getting gain there. And it is possible to create multiple models across multiple pieces of hardware that are actually passing loads among themselves and creating thereby a larger system. So, multiple controllers, half a dozen, 2 dozen, thousands of I/O points, and that is going to be highly dependent on the amount of communication that needs to be had to accomplish that.
Awesome. I'm glad you've been able to address all the things we've been firing your way. I'm going to open it up to a bit of a broader discussion. And Tyler, I'd like to get your perspective first, since you're close to this solution, but then we'll go a little more general. One of the reasons we started these happy hours, I mean, it's been like 4 months since we started them, was because we couldn't travel anymore, shelter in place. And I'm curious, with the capabilities of something like this to, limit the amount of on-site things, what have you seen from Emulate3D? And then I'd love to hear from everyone else in general. What have you seen from digital twins in general over the last 4 months, if you've seen any growth, increased usage, etc.?
I appreciate that. We have seen, I think I can say, we have seen an increased demand for the ability to, especially as it applies to virtual commissioning, that people are starting to think about the future and saying, if this is quote unquote a new normal, and I think everybody hates to think that, but if we have to at least adjust the way we're working, that this adds to the value of the tool, right? We also see on a couple of different, maybe a different points, we also see a pretty decent segment of our customer base, whether that's Amazon or Walmart and Target and others, who are seeing a huge increased demand for automation and optimization. And this is a tool that fits squarely in those kind of pursuits. One more thing, because people are working from home, it seems to me, you could probably find reasons to say this is not true too. It seems to me that people are finding time that they didn't otherwise have to do the kind of things they wish they always had time to do, and doing things like, doing a digital twin is one of those. In other words, it seems like a lot of those things that maybe we have traditionally gotten bogged down with in office settings or in traditional face-to-face settings, we're being free to not have to do some of that. And so that's going away, and people are starting to spend some time doing things that they otherwise might do. So we're seeing, actually think, I think there was a lot of things that were put on hold. There were some things where people were saying, we don't know what we're going to do, but are now saying, yeah, this is one of those projects and one of the things that we can now spend time on that we couldn't, or that's going to give us more value than we thought it would based on the new environment.
Any other perspectives on that? I know we're all out there poking around the industry right now. What have the rest of you been hearing? If anyone wants to raise their hand or speak up.
I think it's interesting how the term digital twin takes on different meanings depending on whether you're in a discrete manufacturing or a process standpoint, or a greenfield environment, or a high fidelity simulation environment. It's being used in a lot of different demeanors, I guess, depending on your domain expertise.
Yeah, Tim, you're right, and it's one of the reasons that I tend to, the first thing I do when I'm talking to a customer or a prospect is say, let's talk about when I say digital twin, what that means. And I'm not saying I'm right. I'm just saying I want you to understand what I mean by that, because they'll probably have a different meaning for it. So you're exactly right. And I've actually, it's almost sometimes gotten uncomfortable for me because I've been on the phone with somebody else who insists that their description of digital twin is right. And that's okay. And that's why I've kind of sometimes retreated to saying, well, let me tell you what we do. We do emulation. Let me tell you what that means to us, right? And so, yeah, I think you're exactly right.
Yeah, I'm not saying it's good, bad, or indifferent. It's just, depending on what sector you're talking to, digital twin takes on a total different meaning.
No, I totally agree with that. There's no qualitative judgment at all. It just is what it is, and so it's sometimes something that has to be level set for sure.
I think the thing that I'm enthralled with is the ability to take a 3D emulation like you have here, or a 3D laser scan like other technologies, and combine those with real-time data, right? So that you can now take an OEM or an end user, even if they're having a problem in a working environment, through how to troubleshoot it in a virtual environment.
Yep.
Or whether it's testing and validating to get to a commissioning state, or 2 years later, what does good look like, and how do you get the right people involved at the right time without actually touching your physical facility.
Okay, I just made the serpentine railgun, guys. Here it goes. It's what the first builder of Emulate3D does every time. Let's see what happens. I better back up. We're going to have a problem in just a second.
I have to say, as I'm watching this, I could watch those boxes come off all day, because they always land in a different way, in a different place, and it is just absolutely mesmerizing.
I wanted to say the exact same thing that whole time.
That was
like
nearly
verbatim.
Nearly fast enough. It's really funny you say that, because we do a lot of live demoing. I mean, our first goal with any customer once they're qualified is to get in this environment just like we are, right? So it'll be me and maybe Mark Sarvo, who somebody met, or Mark Emiot, and we just open it up like I just did, and we start working on it. And we can get into the low-level detail, and that stuff is really cool. But inevitably, when we hear the wows and the gee whizzes, it's like, oh, cool. Look, they're falling on the floor. That's so cool. And we're like, well, wait, you can actually create logic in here that'll actually mimic the way your real system works. Well, I know, but look at those boxes, right? And so there is this something about it that is rather mesmerizing. And then you start to mess around with different sizes and different shapes. And I thought I had this speed turned way up. But let's just turn this up to, what I have, 1,000 feet per minute. That seems fast enough. How about 10,000?
I was going to say, it looked like it had a little catapult effect to it.
Yeah, this is where you start getting some what we call quantum problems. It's probably, it's not long enough to get enough acceleration.
Okay.
Yeah, the acceleration
issues, right?
Yeah. But what we can do is, for example, if we change the length of this to 100 feet, then we start to get the railgun effect, right? We have some time for acceleration. There they go. Okay. So yeah, it is quite mesmerizing, and if my printer would stop doing that, maybe even.
Oh, there! Wow.
Yeah.
And now you're getting fancy with it.
Now,
Tyler, is there anything you wish we would have asked you that we didn't on this call?
No, I don't think so. You know, it's a relatively deep and relatively broad software. There's a lot of functionality here. We tend to focus a lot on the virtual commissioning because of the nature of what we do at Rockwell. I would simply say, don't let yourself be limited in your imagination by what this can be used for. If a customer says, well, we don't do commissioning or we don't do controls, but they're an OEM or they're a system builder or even an end user customer, there may be really good applications there. And I'm happy to have a chat with any of you at any time just to talk about, you know, what an opportunity might be. And we never, even after 15 years of doing this, we are still surprised sometimes when a customer comes to us and says, here's what we used it for. And we go, you know what, we never really imagined that. Our classic example is somebody showed up at our user group meeting and they showed us the demo that they had proposed, but they said, can we show you something else? And we said, sure. And they popped up a model that they had made for a customer of a chick hatchery. Because in these big chick hatcheries, as soon as the eggs hatch, all the chicks get thrown on a conveyor and they wind through a conveyor and then they go to a sorting area and the sexers sort them and they throw all the male chicks on one line and all the female chicks on another line and all the deformed ones. And they actually had a model that little baby chicks moving down a conveyor that were being sorted by hand, and they were looking at throughput and how quick people could do things. And you know, it's Chris is making an ew face. Take another sip.
Oh, yeah.
Take another sip.
I've been in one of those plants
we
before.
would have never put, you never would have put on an application sheet chick hatchery facilities, right? This doesn't happen. So, feel free to hit me on Teams or call me anytime and say, hey, I have a customer that saw Emulate3D, but they don't do controls, but they were thinking maybe they could use this for X. And we can usually answer that question really well in just a couple minutes and get to a customer that may not otherwise have seemed like the right application. So.
Tyler, can you remind me your email since we've got a lot of people from outside the organization on this call too?
Tyler.Phillips, Tyler.Phillips at ra.rockwell.com.
Perfect. I'm popping that in the chat right now for anyone that wants to follow up with Tyler after the call.
Yep. And if you want to put my mobile phone in there as well, because I'm kind of, as you can tell, I have never turned my camera on. Hold on, I better do it now. I was going to say, as you can tell by looking at me, I've used telephones for a long time. Me and Bill have the same hair color. Well, me and Tim have the same hair color too. So let's see here. I don't even know where my screens are anymore. I'm totally lost. I was going to turn my camera on.
I'm popping your phone number in here while
all right.
While you hunt that down.
Yeah, I was going to turn my camera on, but there's meeting controls right there. Let's see. Oh, here we go. Hey, there I am right there. So, yeah, you can tell I've been answering phones for half a century. So, yeah, if you call my phone, I still pick them up.
Well, Tyler, we really appreciate you going through everything today. I'm sure you probably haven't been checking the chat as often as the rest of us have, but a lot of accolades for you. So, since we are getting towards the end, I'm going to raise a glass to you one more time if anyone else wants to join me. Thank you for the great demonstration, Tyler.
Yeah, cheers.
And I'm going to try to keep mixing these demonstrations like this in on a monthly basis within our rotation. as we get towards the end of today's happy hour, the next two that we've got coming up, next week is going to be a fun one. I'm surprised it took us this long to get meta, but we are doing one that's focused around smart manufacturing and technology in the brewing industry in general. We're going to bring a few folks from that space on there. So that should be a lot of fun. I know a lot of us don't necessarily delve in the beer industry, but I think, consider that one kind of a fun one. I'll probably have some beer-centric discussions in there as well to add
Is that
to
one
that.
scheduled already?
Well, it's not on the schedule yet. I'm about to send that out afterwards.
Okay,
so
great.
You'll get that. Everyone on this call, I think, is on the regular list that gets these. I try not to bombard my whole email list with every invitation. So, but I'm looking at the folks on here. You're the core group that we always have. So you guys should be getting them. And I know almost all of you are in the industry community where I make sure to post the links as well. And then following that one, the last week, we'll do one of our typical roundtable conversations, more of a bring a friend, get to know everyone in the group type discussion. And that'll take us through July. And I think that's all I had. I have the link to the happy hour community in the chat. It's probably 5 or 6 behind now, but pop in there. I think most of us are in that group. And with that, thank you guys for coming this week. Always a good time, and looking forward to another session next week. And a big thanks to Tyler again for leading us through the demonstration.
My pleasure, guys. Reach out to me anytime. It's good to meet some of you new and good to see some of you again.
Great job, Tom.
Okay, thank you.
You bet. Have a good night.
Good.
Thank you very much, Tyler.
Cheers, everyone.
You bet.
Have
My
a
pleasure. Take care.
great rest of the week.
Cheers.